Fractional distillation is a process by which components of a chemical mixture are separated into different fractions according to the different boiling points. It involves the evaporation, condensation, and further recollection of the species in increasing order of boiling points. The process is performed in a fractionating column, in which the temperature decreases gradually along its length. Let's see how this works. A chemical mixture with different boiling points is heated up. When the mixture reaches the boiling point of the most volatile component, a vapor phase will start to form, made up of this component in vast majority. Then, as the temperature continues to rise up, multiple cycles of evaporation and condensation take place. Each cycle is known as a theoretical plate. In each cycle, the composition of the vapor phase in the column is formed by the most volatile component. This is why, when the top is reached, the final product is almost pure. Now, let's review some applications for this process. Fractional distillation is one of the most important and used methods in separation of liquid mixtures. This technique of physical separation presents lots of benefits that can be observed in the huge amount of applications both in industries and labs. For example, the purification of oxygen ethane. In labs, it is used for the purification of reactives and products, also for recycling samples that were already used. But one of the most important applications for this type of distillation is oil refining. Oil is made up by hydrocarbons that have many components. This means that boiling points are not as separated as expected. That's why this process is carried out in enormous fractionated columns specifically designed with a long interval of boiling points. The most volatile components, like gasoline and naphtha, are collected near the top of the column, and heavier components like lubricants and non-desired fraction are collected near the bottom. As shown before, fractional distillation is able to separate substances with narrow differences in boiling points, making this process vital in the world of industries.